Lesson 3-5, scatter plots and lines of fit. So guys, basically what we're going to do is we're going to look at patterns still, but the patterns we're looking at are in the graphs. So what we're looking at when we're looking at the graphs is we're looking at the relationship between two sets of information. So for example, in the first graph, we're looking at the hours after sunrise and the temperature in degrees Fahrenheit. For this graph, we're looking at the age of the car and the car value. And this one is shoe size and then their test scores. Okay, so what we're looking at is basically what do we see happen as we see one increasing. So as the hours after sunset increase, so as it gets later in the day, what is happening to the temperature? We see that the temperature is also increasing. So what we would say here is that this has a positive association. Because as one increases, so does the other. Okay? Next, we look at the age of the car. Now, when we look at the age of the car is getting older. 1 year, 2 years, 3 years, 4 years, 5 years. And then what is happening to the value of the car as the car gets older? Well, we see that the value, the points are getting lower and lower, which means the value is dropping. So we would say that this has a negative association. Okay? And yet we always look at x. We're looking at it as it increases this way. What is happening to the points? Okay, from left to right. Here, the shoe size. So we're looking at the shoe size of different students and their test scores. And here we see that there is no real pattern, that they're kind of just all over the place. So someone with a smaller shoe size can pass and fail the test. Someone with a bigger shoe size can also pass and fail the test. So in this, we see no association. Basically, as the shoe size increases, we don't see a relationship between the points, whether increasing or decreasing. So we write down no association. And that's it. All right, so let's go on to example number 2. How can they be modeled? So if you look at it, I'm ignoring number 3. I'm ignoring the shoe size because there was no association. I'm not going to worry about trying to represent a model for that. But we know that there was an association with these two. So we're going to try to create a model for the information we have. So these are the same two graphs. This one had a positive association. This one had a negative association. But the difference now is we are going to draw a line through the data. And the line is the model for what is happening to the points. So in this case, I'm sorry about that. In this case, we see if we draw a line, the line would be something like this. Now, you have to understand something. I'm not trying to connect all the points. I'm actually just trying to figure out which way the points are going in a straight line. So you're not going to touch all the points. What should happen is you get a number of points above the line and a number of points below the line that are about equal. I'm saying that if, let's say there were 10 points, you would see about 5 points above the line, 5 points below the line. Because sometimes the line won't even touch the points. Like here, it looks like maybe I'm touching 3 points. Here, it looks like I'm touching 2 points. But you don't even have to touch any of the points. You're trying to get through the middle of the information. And when you can draw a line, we call this correlation. So this has a positive, and I think I just misspelled positive. I apologize. No, actually I didn't. I'm sorry. I misspelled it the first time. That's why I don't teach English. And this one has a negative. Correlation. So when your line is basically has a positive slope, the relationship between the hours and the temperature are increasing. So the longer in the day, the warmer it is. Here, as your car gets older, the value of that car goes down, so it's a negative correlation. So when you draw the line, that's when we talk about the word correlation. There is a relationship between these two that is increasing and the relationship between these two that is decreasing. Okay, so let's move on to the next one. Now, trend lines or lines of fit. I'm used to saying lines of fit, but in this book we use the word trend lines. So let's talk about this example for a second. Right here, they want a trend line that is in this scatter plot. So this is a scatter plot right here that is modeling the information about the years from 2000 going forward. So this is 2004, 2008, 2012, 2016, and we don't have the information for 2020. And on the y-axis, we see the number in the thousands of hybrid cars that are sold. So that first dot would be somewhere around 50,000. This next dot would be over 200,000. And that's how many of hybrid electric cars were sold in those years. Okay. Now, what we're going to try to do is make a trend line that is a model for what's happening to the sales of these electric hybrid cars. So what you want to do is you want to draw a line through the middle. Something like this. So if you take a look at that, the line that they use that's going through the middle is not even the points that are there. If you take a look at that, they chose these 2 points right here. Now, the reason for choosing those 2 points, if you look at all these points, they're kind of not in the corner of these lines, so we don't know exactly what value they have. I don't know exactly what number this is. I'm assuming it's 50,000, but I could be wrong. So what we do is, okay, if we draw a line through the middle, what other points can we use that we can use their numbers to determine the pattern? So they use a point right here for 16, they use 500,000, and for 2, they use 50,000. And now those 2 points, I'm going to write those 2 points down. I'm going to use these 2 points to make a trend line for this information on the scatter plot. Okay, so here's what we are asked to do. We are asked to make a line, an equation of a line. So guys, we're using y equals mx plus b. That is the equation we're going to use. So we're going to do that right now. Let's go over these steps because it's been a little bit of time since we actually used these formulas, but let's review them. If we're going to make y equals mx plus b, slope, intercept, first thing we're going to do is find the slope. Then the second thing we're going to do is find the y-intercept. And then the third thing is we write the answer. Step number 3 is you write down the answer in this format. So we're going to start with number 1, find the slope. So number 1, we're going to use the slope formula, y2 minus y1, x2 minus x1. Now in this point, I'm going to say this is x1 and y1, this is x2 and y2. So I'm going to put 50,000 minus 50 and 16 minus 2. We don't need to put the thousands because in the graph they told us it's in the thousands. We can just use 550. So we subtract that, I get 450, and 16 minus 2 is 14. Okay, because we are actually not graphing it, because we already have the graph, we're going to use this as a decimal. So I'm going to write down the slope as a decimal. So I'm going to divide 450 divided by 14, and I'm going to approximate it, 32.14. So approximately 32.14. Okay, so now let's go on to step number 2. I gotta find b. Now, guys, to find b, you have a couple of choices. In the past, what I've asked you guys to do is you're gonna write down the formula with your slope, and to find b, you're gonna plug in a point. You're gonna plug in one of these points. I'm gonna go with the smaller point. I'm gonna go with this one. I'll plug in 50 over here and 2 over here. Okay, I multiply this times 2, I get 64.28 plus b equals 50. Okay, I gotta subtract. From both sides. And my answer for b, let me go back to my calculator, is negative 14.28. So I have my slope, I have my y-intercept, my answer, step number 3, my line is y equals 32.14 x minus 14.28. And that is my answer. I'm just going to double check my answer in my calculator real quick because I already made a mistake in my spelling. I don't want to make another mistake in my calculations. So yeah, I'm good. And guys, this is the trend line. This is the line of fit. Now, I'll be honest with you guys. If you guys go to the book will have a slightly different answer, and that's fine. We're all going to have slightly different answers because we get to choose our points. We get to choose the points we're working with. You can end up with slightly different, but they will be all closely related. Like our slopes could range from 30 to 35. Our starting points can range from maybe 10 to 15 or negative 10 to negative 15. We're going to have different, slightly different answers, but that's okay. That is not a problem. Okay? All right. Let's go to our last example, example number 4. Interpreting the lines. So to interpret the lines, here what we have is a table that represents the download of a 100 megabyte file from various internet speeds. Assuming the trend continues, how long would it take to download a 100 megabyte file with an internet speed of 75 kilobytes per second? So basically, when you look at these numbers in this table right here, you have a slow speed at 35 kilobytes per second and a fast speed of 60 kilobytes per second, and this is how long it takes to download that file. Okay, now to make an interpretation, they want us to figure out, okay, what if we get to 75? How fast would that be? We need to make a trend line. Okay, sorry I had a little jump there, but for sake of time, I'm going to skip the graphing part of it because to make a trend line, you need to take that information and graph it. So the internet speed is your x-axis. The time it takes to download, which is in minutes, is right here. And then if you graph this information, let's see, 35 seconds takes 6.65, that'd be somewhere up here. 40 seconds takes 5.58, somewhere over here. And then 45 seconds, 5.17. 50 seconds takes about 4.65. 55 seconds takes 4.23. And then 60 seconds, 2.88. So it would look something like this, right? And then you would draw your trend line right here through the middle, something like that. And you would use 2 points from this line. Maybe I would use possibly these 2 points and then make my function. So if you look in the book, it looks like this. They chose 2 random points. I'm going to choose 2 points that I have. Okay, so you can follow their model. They did the same thing except they used point slope. I'm going to do the same thing I did earlier. So I got my 2 points. My 2 points is 35 and 6.65 and 60 and 3.88. So these are my 2 points that I'm going to use for this problem. Okay, And I follow the same steps that I showed you earlier. I'm going to find slope. Number one, find the slope, which in this case would be 3.88 minus 6.65, y minus y, and then 60 minus 35. And then I use my calculator. This is where you would use your Desmos calculator too. I would assume you're using Desmos, but you would use 3.88 minus 6.65, and I get negative 2.77. And then I would take 60 minus 35, and I would get 25. And then I would divide these numbers, and I would get negative 0.11. There's my slope. Okay, step number two. I'm going to find b using negative 0.11. And I'm going to take one of the points that I used. I'll use the smaller point. So the y is 6.65 over here. And 35 goes over here. Okay. First thing I'm going to do is going to multiply that times 35. And I get negative 3.878. I'm rounding. I got to solve for b, so the opposite of doing this is to add. So I'm going to add this number to both sides. And I get, I'm going to round this answer, 10.5. 10.5. All right, so this is my b. So my trend line here would be y equals negative 0.11 x plus 10.5. That would be what I have. Now, I would use this information. Sorry, I didn't mean to click that. I would use this information then to make predictions about my line. So in the question for this problem, if I look back at it, let me go back to the question real quickly. It was asking how long would it take to download a 75 kilobyte file. So, with 75 kilobytes per second. So if I want to plug in 75, I would use my calculator to plug in 75 and get my answer.